Hello and welcome to the Waves summary lesson. This lesson only contains combined science content and it'll cover some of the key aspects from the series of lessons before. My name is Mr. Pratt, Director of Science. Off we go. So, you're going to need pen, some calculator work in this lesson, so make sure you've got a calculator, paper or exercise book to do some recording in, and unless you're having to watch this video on your mobile phone, turn it over, switch it off, get it out of the way, try and avoid any distractions that you can avoid. Starter then, picture of a wave. Just recall from a couple of weeks ago, I want you to label the wavelength and amplitude. There's several places that you could put this on. If you can put it on more than one place, great. I'm only going to give you 30 seconds. Right, so you could put the wavelength peak to peak. Just make sure that you are going to one peak to the very next peak. Be careful with your arrow in an exam. Lambda there, that's a symbol for wavelength. Or you could put it from the central position to where it repeats itself again. And you'll notice that red line is the same length as the other red line. Or you could put it on trough to trough across the bottom. Amplitude, be careful. It's only halfway up, so it's the displacement from the mean position, the middle position, up to the highest position, or you could do it down to the lowest. Again, the arrow should be the same size. So first outcome, recall and apply the wave equation. So that's going to come up, it's always coming up, you're going to use it, and we're quickly going over the three required practical methods again, or bits of them at least. Aspire outcome, we're going to have a look at the wave equation again. I'm just going to give you a question at the end that's possibly an unfamiliar context, something that might throw you, that we could just talk us way through it. So I'm going to give you two minutes for this. So worked example, just finding the frequency using a graph. We've got time in milliseconds on the bottom, amplitude up the side. I've got steps 1, 2, 3 there. I just want you to follow them and try and find out the frequency of that wave on there. 2 minutes. Minute left. If you finish early, you can give me the amplitude as well. Okay, should be just finishing off. So mark the time for one complete wave. Most sensible thing to do would be to start from the beginning at 0 milliseconds. And there's one complete wave, so up, down, past the middle, back again, 20. But but it's not 20 seconds, it's 20 milliseconds. So we've done that, 20 milliseconds. Always a good idea to convert straight away. 20 milliseconds is 20 thousandths of a second. So 20 divided by 1000 is 0.02 seconds. Use the equation. Time is 1 over frequency. That formula is given in the exam. So we're going to calculate the frequency. So we need to do 1 divided by, so 0.2 is 1 divided by f. So f is going to be 1 divided by 0.02. So 50 hertz. Just a link to electricity there. 50 hertz is the frequency of AC electricity that we get from the national grid through a main socket. Right, you've got a total of about 4 minutes here. If you need more time, then you can pause it, but they're quite short, snappy answers. So I just want you to work your way through. I'll do one clock and then I'll do the other. Pause it if it's a bit quick for you, or just zap it at the end if you've finished early. Okay, it's got 2 minutes left, so you should be past halfway really. Thirty seconds then. Thumbs up. What did you do then? We taught you through it then. So, what the top parts of the wave called? So that's the peaks, peak on a cap. What the bottom part called? Troughs. What is one complete wave cycle? So, if we've got a wave like that, it's the distance it takes for the wave to start repeating. So it goes from there up, down to the bottom, back up. So that's one wave cycle. That's two wave cycles. Definition of frequency. So that's the number of waves per second, the number of waves in a second. Symbol for frequency, capital H, Z. Oh, done that the wrong way around. So that's the unit of frequency, hertz, capital H, Z. So the symbol for frequency is just F. What does 15 hertz mean? So if frequency is the number of waves in a second, it means we've got 15 waves in 1 second. So with 600 hertz, we've got 600 hertz in 1 second. Relationship between frequency and time. So because frequency is the number of waves in a second, frequency is 1 over time, number in a second. So frequency, what frequency does a wave of 0.2 seconds time period have? So the frequency is 1 over time, so it's 1 over 0.2, which is 5 hertz. So that's the same as 5 waves in a second. Questions for you, more calculation based. So I'm going to give you 4 minutes again, just with two 2-minute timers. Off you go. Okay, that's half your time. Should be on question 3. If you found it a bit easy and you finished already, just do question 4 again, but let's say that the frequency is 9.4 kilohertz instead. minute left. Okay, quick if you haven't done. Links frequency, velocity, wavelength. So velocity equals frequency times wavelength. So waves of 38 hertz, wavelength 0. Meters calculate velocity. Velocity equals frequency times the wavelength. 38 times 0.18. 38 times 0.18. 6.84. And that's the velocity, so it's meters per second. And the velocity, so same again, we know the wavelength, this time it's 2.6. And the frequency is 460. So velocity equals frequency times wavelength. So velocity equals 460 times 2.6. 460 times 2.6 equals 1196 meters per second. Underline the answer. Wave has a frequency of 9.4 hertz, wavelength 3.2, velocity equals frequency times wavelength. So it's 9.4 times 3.2. 9.4 times 3.2. 30.08. I'm going to take that to three significant figures. 30 point, that's bigger than 5, 1 meters per second. Last one. So this time we're finding the frequency. We know that the wavelength is 0.8 and the speed is 3.8. So write the formula down again. Velocity equals frequency times wavelength. Now substitute in, before you do anything else, we know the velocity is 3.8. We don't know the frequency, we're trying to find it, so I'm just going to leave f, times the wavelength, which is 0.7. So if 3.8 equals the frequency times 0.7, if we divide both sides of that equation by 0.7, 0.7 divided by 0.7 gives you 1. So that means that the frequency equals 3.8 divided by 0.7. 3.8 divided by 0.7 equals, I'll write the whole number out, 5.428571. I'm going to go with three significant figures, 5.4, one more, that's bigger than 5, so it takes that up to 3. Now this time, because we've found a frequency, that unit is hertz. Okay, that apparatus, I'm hoping, looks familiar, the Leslie Cube. I wanted to describe and explain what results you'd expect from this experiment. Minute left. So we've got describe first of all, so we just need to say what we would see, what we would observe from this experiment. So we've got matte white side, matte black, shiny silver on the other side, shiny black on the back. So what you would see that the amount of infrared radiation on that detector depends on the colour. So the amount of infrared radiation emitted from the cube depends on the colour of the side. So we've described it. Explain it. You remember which side will emit the most? Matte black. The matte black is the best emitter of infrared radiation.
I need at least 13 seconds.
Well, you have done already 14, 16.
apologies for the quality of the photo here, but let's just run with it. So I'm going to mark on the 0 line of the ruler, I'm going to get a line right across that marks the start of where we're going to measure from. So I'm going to go from there, so that would be 1 wavelength, 2, 3, 4, 5, 6, 7, 8's just gone past the end of the ruler, so I'm going to use 7. So 7, go across to the ruler. So I've got 7 waves in how many centimetres? So that's 26.6 centimetres. Now, if we're going to use wavelength later, applying it into an equation, that'll need to be in metres. So let's put it into metres now by dividing by 100. So 26.6 divided by 100 is 0.266 metres. But that's for 7. So to get 1 wavelength, we need to divide that by 7. 0.266 divided by 7 equals 1 wavelength is 0.038 metres. Okay, on this one, so this is the second part of the measuring waves practical, where we've got waves on a solid vibrating string. So for each of the 4 patterns, I want you to state how many wavelengths you've got, and then for the top one, if the frequency is 200 Hz, I want you to find the velocity. So that'll be using the wave equation again. Okay, 30 seconds left. Let's have a look at the first bit, number of wavelengths. So I'm just going to go down and I'm going to pick the second one. I'm going to pick the second one because it's the easiest. It's 1 wavelength, so the wave is going up, down, back again, and the red wave on top is the reflected wave. So that is 1 wavelength. I'm just going to write it equals 1 lambda for wavelength. So the one above it is only half of that, it's just the first bit, so that's half a wavelength, half wavelength. I'm going to jump to the bottom one, because the bottom one is 1, 2, 2 lambda, 2 wavelengths, and then in between we've got half, 1, 1.5, so 1.5 wavelengths. So if the frequency of the generator that's caused this wave is 200 hertz. Find the velocity of the wave at the top of the string, so the top one. So the equation we're going to be using is the wave equation. Velocity equals frequency times wavelength. We know the frequency is 200, so we just need to get the wavelength from here. We know that the total length of the string is 0.8. So if 0.8 is half a wavelength, one wavelength would be double that. So 2 times 0.8 is 1.6. So we've got a wavelength, I'm just going to write it there, 1.6 meters. So the velocity equals the frequency, that's 200, times the wavelength, and we've said that's 1.6 meters. So 200 times 1.6 is 320 meters per second. There's a unit. Underline it to catch the examiner's eye. Okay, so just got an unfamiliar context here. Diagram of a cliff, two people, one shouts hello, and then they hear themselves 1 second later. A second later means 1 second. So explain as fully as you can why this happens. You may answer on the diagram if you want to. So I'm just going to give you 20 seconds-ish thinking time, then I'm going to talk you through it and then extend the question a little bit. Just 5 seconds. So this is an example of the exam board using a context. So just from the diagram, they've got cliff, a couple of people, shout hello, and then hear themselves a second later. So we're talking about sound waves here. Sound waves, longitudinal waves, just for a bit of a recap. So this sound wave would go, it would go in all directions, but we're only interested in the cliff. It would go, hit the cliff, and return. So what you want somewhere in your answer reflected sound wave. There'll be a mark for that. The sound wave's reflected, and there's a name that we call sound waves when they're reflected, which is an echo. Echo, echo. So an echo is when the sound waves travel somewhere, hits a flat surface and reflects back, and you hear it again. So reflected sound wave. I'm just going to add a little bit of this so we can get a bit more out of it. I'm going to put on we've got 1 second, so we've got a time. And if I told you the velocity of sound, it does vary a little bit to do with air pressure, temperature, humidity, etc. But let's just take 340 meters every second. So we'll take that as the velocity. What we're going to do in this question, we're going to find the distance to the cliff. So we're going to find how far they are away from the cliff. So it's a straight velocity, distance, time question. So we know the velocity is 314 meters per second. We know the time is 1 second. So I'm just going to substitute into the velocity equation, but there's a bit of a catch. So I'm just going to do it first. So velocity is distance divided by time. So we know that 340 equals the distance times the time, which is 1 second. So 340 equals distance divided by 1, which means that that distance is just 340 meters. There's a catch. That's not the answer. You've dropped a mark if you just do it like that. Any ideas why? Because that distance that we've just found is the distance for the sound to go from here, from Dave and Maureen, to the cliff and back again. So that 340 is the total distance, so that distance is just half of it, 340 divided by 2. Okay, so 340 divided by 2 is 170 metres to the cliff. Okay, just need to complete the Google quiz now. This will be marked automatically and you'll get your feedback straight away. Well done for working on that. That's it for waves, unless you're doing triple science, in which case there's some further lessons that you'll need to do. Okay, so summary. I've put a set of diagrams on there now. Velocity, time, frequencies and amplitudes, wavelengths, and then you've got the 3 bits of the required practical. Pause the video and record what you need to record if you want to have a nice summary in your book. If not, I'll see you next time for a different set of physics topic lessons, or I'll see you for some of the triple lessons if you're doing triple science. Bye.